So hello and welcome to this video on our Coal Mine Meeple puzzle or exercise on futureskill.com. So there is a separate video where I explain the problem and what you should do. There is like an easier level 1 problem, more to warm up so to say, and then a more tricky level 2 problem. And in this video I'm going to try to solve the problem using ChatGPT. And if we look here, this is the problem, this is the starting position. No, actually I've moved it one step. This is the starting position. Or actually it's this. So the red ones start at the top and the blue ones at the bottom. And we call these meeples, the players or whoever, the representation of guys moving around in the coal mine. And this is what you want to achieve. So the red ones should switch from top to bottom and they only move around in this little maze or coal mine, and they cannot occupy the same space and so forth. So this is very cramped here. Looks a little bit like an E, this playing field. If we go to the editor, it looks like this. And what I'm going to do now first is to build a kind of a question or instruction for ChatGPT. Okay. So just copying here. So this part actually has level 1 in it. So I'm going to remove that part in my, so I can actually bring in the text file I'm using. It's here. So I'll try to build an instruction here for ChatGPT. Please solve this, the below programming exercise on futureskill.com in Python using a graph to represent the playing the squares of the coal mine and use tree search. Use a tree search algorithm to find the solution. And then the intro comes here. Here are the main square pairs with the meeples can take steps between. Maybe I can put here, it's a good idea to represent the coal mine with a graph. Okay, and then we go to level 2 here. So it still says this is not correct actually. Something wrong here. So I should remove that. Your program, this part is true though. Your program should return the solution as a list of integers which pairwise represent moves on the grid. For example, if start of the solution is 1, 4, 4, 5, it means that the blue meeple starting at square 1 takes step up square 4 and then I'll step. Yeah, that's correct. All right. So we have that. There's no API, but we have this one. This is the starting code. Here is the starting code. We can remove level 1 because I don't want to confuse it with that one. Solve level 2. Okay, so this is basically what we need. And then I can take a screenshot here. This is the start, this is the end actually. So I'll make a screenshot of this one. Maybe all of this. I think nowadays it can make use of that as well. sometimes. Okay, so let's go to ChatGPT. And we input, maybe I should start with the image. Why not? Let's try, have it somewhere else as well. Board starting pose. Okay. Let's try to reload. Why not? Is it too big? It's 85 kilobytes. Yeah. Okay, so it will not have that. Actually, it's not needed, but maybe it could have helped, I was thinking. Let's go back to these instructions here. Okay. So here we have something. Let's start by putting it down here and see what it did. Level 2 switch sides, that's the correct name of it. Yeah, self API. So it seems I can, maybe I should just keep level 1 for simplicity, but I can actually put it here at the bottom. If I'm going to paste in, I'm not thinking it will be solved in the first step. I also even think that it might take too long to run it, possibly. Feels like a simple problem, but it's also quite big. Yeah, that's kind of expected. So the graph, it does 0 to 1. 1 can go to 0 to 4. Why? Aha, because it's double. Yeah. Yeah, okay. It actually understood that. That's good. 2 can go to 1 and 3. 3 can go to 2, etc., etc. Okay, so that's some kind of graph there. Initial blue, initial red. All right. Is goal. Yeah, that seems correct, I guess. Get moves. Actually, what I should do, since this took too long, I think I should actually go in and I can raise the, with some work here, I can raise the runtime, which is allowed, which I should, of course, have done before, but let's do it now. I still have to do some trickery here in the editor, free code creator. So what should I put? 60 seconds. Let's try 60 seconds. Yeah. Now it should be 60 seconds max runtime. Like so. Okay. Yeah. So we go back here. So now it run again and see what happens. So now it's instead of 5 seconds, has 60 seconds max runtime. Let's see if we can find something that it has misunderstood. Or actually, what I can do here is I can ask it to do some printouts, so I get to see the tree. State blue. Wait, yeah, I don't think this is very good. Okay. So I'm going to ask it to instead of using a dictionary, for the state, please use a tuple. So it should be a tuple with first the red team's indexes sorted, and then the blue team's indexes sorted. For example, so they can, for example, the starting position would be, it was the starting position, then the red are at the top. Actually, I should say first use with first the blue team, let's say, because they start with the lower indexes, then red teams. So then it would be 0, 1, 2, 3, 8, 9, 10, 11. I think this is more efficient, and also it's what? I can't send instructions now. What's happening? Reload. Oh my god, what's happening now? Everyone has bugs. Yeah. I'm soon gonna ask it to do some printouts as well. Yeah, this is exactly the goal state. So it understands things so well, kind of. Which is interesting. So we copy the code and we try it again. Now I trust it a lot more, so I'm gonna just replace everything except level 1, because I think I need to have a level 1 there. So yeah, I was just trying the second version here from ChatGPT after some instructions. Try run code now. Wow, crazy stuff. That was enough to solve it. Yeah, that's crazy. It's actually, I don't know if it's improving over time, or it just feels like it's getting scarily better. That little short, I mean, I just had to give it one little push in the right direction, and I didn't even understand. I mean, I didn't look through all the code it did. I just found one thing that I could improve on. And when I told it that, that was enough. Kind of crazy. It's moving a little bit more, kind of changing which meeple to move all the time, but that doesn't matter at all. So it actually solved it. Okay, so that's how you solve things with ChatGPT. So all I did was kind of pasted in, I did some initial instructions, and I pasted in our description and also the starting code here. And it understood very well from that. I couldn't upload an image. Then I got this code, and I found one problem with it. It was how it was representing the state here, which felt inefficient. And yeah, and I just gave it that feedback to change the state to more simple tuple, which is immutable. And after that, it gave me the solution which actually works. Yeah, that's really, really nice. So it correctly generates the moves. The moves that are, I mean, it did the graph correctly. Yeah, we saw that in the first iteration. It generates the moves in the correct way. Quite a lot of code to generate the moves, but it's doing the same thing a little bit over again here. Could probably be simplified, but anyway, it sets the initial state, initializes a queue, basically the tree that it's going to look through with the initial state. So here it keeps a list of all the states that are left to explore, and here is the steps needed to reach that state. It does a set for a visitor, so that's a cache to make sure that we, like I showed before in this tree here, we want to make sure that we don't visit the same state over again. Okay, I can't, but for some reason I can't. Something got a little bit broke when the video ended there. Oh, now it's there. Yeah, so in this tree here, we want to make sure that we don't go back to states that we've already seen. So that's the cache that we are building, and that it's calling visited here, a set. And in that set, we're going to put all states that we've seen already. And this is the actual, basically the solution where we go through the tree. So it takes the next state to explore and go kind of downwards in the tree here. So going from here to here, for example, or from here, it will take the next step and keep going down here to some new state, making basically one move. And if it's already visited, then we can skip it. We continue, go to the next, we pop the next state from the queue. And then we add the state to visited, because now we have visited it. So we don't go back to it. If it's the goal, then we have solved it, return the path. This is the base case. If we would talk in terms of doing a, what's it called? Now I lost the name for it. Traversing a tree using in a recursive function. This is the base case, but now we're using an iterative approach using a list or a deck called queue. And then here we generate a new state from square to square. We get from the get moves method that we have up here. Yeah, this one here. And we add that to the new path, so we can see in the end when we found a state which is the solution, we will have the moves in new path here. So we have to take the old path and then we add the additional move going from square to square. That was what we were using, a pairwise approach from square to square. And if we don't find a solution, we return an empty list. And yeah, this little thing here is the solution basically. And then it spent a lot more rows to generate the moves, but that's, for most humans at least, that's a much simpler part of the code. So basically, it starts by creating a list of moves that it should return in the end. It has the current state. It goes from this tuple that we have and lifts out the first 4 to blue positions, the last 4 into red positions, and turns it into a list. So it's easier to work with. Then it goes through here checking for blue positions. So it goes through each meeple, checks if there is a neighbor in the graph, so using this one here, that it can actually go to. So then it goes through all such neighbor squares, and if it's not in blue positions or red positions, it means there's nothing blocking. Then it generates something to add to the moves list here. So it takes all the blue positions and it changes the current one that we're looking at into the new square, the neighbor square. So this is the state after it has made the move. And then we always use sorted indexes, so to make sure that, because it doesn't matter which meeple is in a certain index, so it's the same state. If these 2 blue meeples would switch around, it's still the same state. So we sort the blue positions, and then we do a tuple again from the blue positions and the red positions, which are left as they were, and then we append that as a move with a new state and the meeple index and where it went to. And then we do exactly the same thing for the red meeples, and in the end these moves here will be tuples like this, with all the possible moves that all blue meeples can make, all the red meeples can make from the current state. So in the first state here, and we could ask it to do printouts as well, but yeah, in the first step here, the blue move that can be made is for the number 9 to go to number 7. So if we go to this state here, it would be for this meeple to be here. This meeple to go there. That would be one such state that is possible from the starting state. And they take turns making moves. Let's see, is that actually covered here then? Because it's kind of mixing the red and the blue moves in the same. Is that why the solution? No, that's not. Because okay, they're not taking turns. I forget how the problem works. You can always make a red move, always make a blue move. It's not a game like that. It's just coal miners moving about in a coal mine. So we're actually not. It doesn't matter that it's doing everything in one go. So it's correct to look for all blue moves and all red moves. I was confused there for a while. So anyway, that one that we just showed, that one is one of the possible states from the initial one, and then the other state that can happen is that this one can make a move up. So from the starting position, there will just be one blue move and one red move available. So the list will be too long. And that's a very nice solution from ChatGPT with a super small help. So you can also, of course, go to the language that you want to solve it in using C# or Java or whichever language you want to use. The boilerplate code will change here, and you can just, ChatGPT is very much able to solve this in any of these languages that we have. I just happen to prefer Python myself. Good luck solving the Coal Mine Meeple puzzle.